Yesterday, we did systems of linear equations. Today, we're going to look at systems of nonlinear equations. So it's a kind of a nice little review of all these different functions that we have graphed throughout the year as we start getting closer and closer to that final exam. Maybe a nice little review for some of that. Now, this is more than just graphing a parabola or graphing a line or something. We're actually going to be graphing two equations. So that means we're going to have two different graphs. Sometimes they might be the same. That might be two parabolas, but because you're still looking for where they intersect, different things can happen. There's not going to be just one solution like when two lines intersect. So you have options. So it's maybe worth thinking about a little bit. If you had a parabola and a circle, how many solutions do you think there are? How many intersections would there be? And the answer is, well, it depends. You might have a circle that looks like this, and then a parabola that looks like this, and then you would have two solutions. But you could also have a circle and the parabola might go all the way through. You might have four solutions. But what if your circle and your parabola came down and just touched and then kept going back up? Then if it only hit once there, now you're at three solutions. Or you could have, oops, that's a bad circle. What if your parabola did that, oops, and hit just once? So I've got a 1, 2, 3, 4. You could even have a no solution. So lots of options of what could happen. All right. Why don't you look at a line and an absolute value? Pause the video, come up with how many different solutions or options would you have for that? Pause the video for just a minute. All right, this is what I came up with. I figured that we could do two, we could do one, we might have zero solutions. You never really know. We're not going to necessarily know which scenario happens until we dig into it. We can go back to our graphing and see what happens on these. So that's where the review is going to come into play. Do you remember how to graph all of these different functions? So looking at this top one, that looks like that's going to be a parabola because you have the x squared. But I'm going to rearrange that a little bit and get the y isolated. So I'm going to move the y to the right, and I'm going to move the 4 to the left. When I do that, I'll end up with a positive y, which is what I wanted, and then I'd have an x squared minus a 4. So I know it's a parabola because of the x squared. Do you remember what's the minus 4 going to do to your parabola? All right, it's going to move your vertex down 4. But that's all that changes. So the shape of it is still going to be 1, 1, 2, 4, 3, 9. And then we put in our matching points. All right, and then we can graph that. It's going to be important if I'm looking for intersections that I plot those points well. Okie doke. This one is just linear. It's an x plus a y. Those are both linear. But I would like it to be in slope-intercept form. So I'm going to subtract the x. And that's my equation. So then I'm at -2 for the y-intercept. And then my slope is -1. So that means down 1, right 1, down 1, right 1, down 1, right 1. Or I could go up 1, left 1. Up 1, left 1, up 1, left 1. Do you see why I kind of want to go both ways? I don't really trust my freehanding my line through here. I want to make sure that I hit some nice points. So my solutions are where it intersects. And I have two places where that happens. Right here at 1, -3. And I have another intersection right here at -2, 0. So those are the solutions to your system. Now, that didn't go so bad. Graphing was all right, but we do have a way to do this algebraically. At least sometimes we can do it algebraically. So let's look at a few where we could do that. All right, so on this first scenario, let's see what you remember about these equations. It's an x squared and a y squared. They're both squared. equals 4. Okay, that is actually a circle. Remember that circle formula? It's like an x minus h squared and a y minus k squared equals an r squared. So this is really your radius squared, and this tells you your center. Now, actually, this is a different graph because of the minus. We haven't really talked about it yet, so I won't dig into it too deep. But when I look at this, I see that these two, they're sort of like lined up with like terms, so that's good. And these are going to drop out. That's going to work great. Let's give it a shot. So I'm going to draw my line. Those are going to cancel. I have 3x squared equals 12. And now I'm going to square root both sides. But right here, remember, when you square root both sides, you need a plus or a minus. So what that's telling me is that the x has a couple options. It could be a 2 or it could be a negative 2. So I'm going to take each one of those answers and I'm going to plug it into one of the equations up here. I kind of like the first one. So I'm going to plug 2 in for x, and then I'm going to plug a negative 2 in for x. If I plug in a 2 for x, then I would have a 4 plus y squared equals 4. Subtract the 4, so y is going to equal 0. So I have a solution there. When x is 2, y is 0. That's one of the solutions. All right, let's try it again with a negative 2. Well, really, if you put in a negative 2 and you square it, you're back to the same equation. So that means y is still going to be 0. So then my other solution point is negative 2, 0. Those are the two places where those graphs would intersect. Okay. The next one is very, very similar. They're actually both pluses on this one, but it looks like you're probably going to have to multiply by something. I'm going to let you do that one on your own. So pause the video, see if you can do this algebra piece by yourself. Come back when you're done. All right, this one played out a little bit funny. It started off just beautiful, and I ended up with my plus or minus 4 when I was solving it. But when I start plugging a 4 back into the original, I plugged it back into this original, that ends up getting me a 16. And when I move it to the other side, it's going to end up imaginary. And even if I put in the negative 4, it ended up imaginary, which really means I couldn't find a solution that worked properly. So this is a no solution. So those two graphs are never touching. Now we do have the option, not always, because I am going to want you to be able to do these by hand as well, but we could graph them on our graphing calculator also. Now I do know that this is like a V shape, absolute value graph, and then I have another quadratic because the x is squared. They might intersect nice, they might not, but we're going to practice doing this on the calculator. So you're going to go into y equals and clear out anything that you have in there. While you're there, go ahead and turn any plots off that you have. And then I'm going to do y equals. You do have to, I guess, rearrange this. So to get the y by itself, I would have to subtract the absolute value of x. So it would look like that. So in my calculator, I'm going to type 4 minus, and then go to your math menu and over to number, and there's your absolute value button. So then I'm going to put the absolute value of x. And then you can graph it, but I don't know what it was the last time, so you might need to fix your window. But a quickie, I love Zoom. And then if you hit 6, it's Zoom standard, takes you immediately to a 10 by 10 window. So I'm just going to do Zoom 6. Okay, and it graphed. I have an upside down absolute value, which is what I thought I was going to have. Okay, now I'm going to go back to my y equals, and I'm going to put in my other equation, which is going to be a y equals x squared minus 2. Now when I graph that, I get a parabola. And so here is, just so that we are on the same page here of what we're looking at. So it's a parabola with an absolute value. The absolute value happened to be upside down, but the parabola was right side up and it looked like that. So, okay, that's not really a great picture. I'm actually going to undo that real quick because it looks like where they're crossing is up above the axis there. So I wanted to make that match a little bit. Okay, so that's what I'm looking for. I have two solutions. What it is, it's the intersection of those. So remember, go to second, calc, and do intersect. And the first curve is my absolute value, and then it automatically goes to the second curve. That's great. Now, sometimes I tell you, you can skip over the guess. Not in this case, because we have two different intersections. So the guess means, hey, scoot your cursor over close to what you're wanting for the intersection so that it'll tell us that one. And lo and behold, it is a beautiful 2-2 intersection spot. Now, because of the symmetry that's going on, I have a pretty good guess that that's going to be a -2, 2. You can always check it, but both the parabola and the absolute value are kind of classic parent graphs with just a tiny bit of shifting on them. So I'm going to assume the symmetry on that. Okay, those are your two solutions using your calculator to get there. All right, let's try some applications here with these different types of equations. We have a right triangle. We have a hypotenuse of 13. So right triangle, hypotenuse is that longest leg across from the right angle. So that's 13. It also tells us that the area of this triangle is 300. All right, well, they didn't tell me much on my triangle, but I guess since it's a right triangle, I could call this the base. That's a B. This is the height of it. That works out really nice in a right triangle that your base and height are just two of the legs. Because what I'm going to do then is I'm going to create an equation that has an H and a B in it. And I have two ways to do that. Well, first of all, I've got a right triangle. So I know the Pythagorean theorem should work. H squared plus B squared should equal 13 squared. So there's one of my equations with the two variables. And then the other one is the reason they gave me the area. Remember that area is equal to base times height. So I know the area is 300, and that's going to equal base times height. Oh, sorry, 1/2 base times height. I'm going to need that. Okay. Now, I think what I would like to do on this one, you have options, of course, but they aren't going to stack very nicely with because you don't have like terms really. So I think on this one over here, I'm going to isolate one of those variables, and then I'm going to substitute over here. That's going to be my choice. So I'm going to divide by the 1/2, which is the same as multiplying by a 2. So that's a 600 equals BH. And just for the heck of it, I guess, I'm going to solve for the B. So I'm going to divide both sides by H. So here's what I've got. B is equal to 600 over H, and that's what I'm going to plug in for B right there. So then I'm going to have on that, I'm going to have an H squared plus, if I take that fraction and square it, I'm just going to square the numerator and square the denominator. So that'd be a 36.4 and an H squared, and 13 squared is 169. All right, next thing I'm going to do here is take everything times, I just don't love this H squared that's in the denominator. So what I'm going to do is I'm going to take each term times H squared, and that way I'm ultimately just multiplying everything by H squared, and it's going to get it out of the denominator. But what's weird is if I take this times H squared, well, let's do it like that. Then I'm going to end up with an H to the 4th plus the second term, the H squareds drop out, and I just get the numerator there. And then on the last one, I'm just going to have 169 H squared. I'm wondering if you see what's happening with this. What would we do with something like that? Well, you have an H to the 4th, and then you have an H squared, and then you have a constant. This is actually going to be a factoring problem. H to the 4th minus the 169 H squared equals, sorry, not getting my signs right, plus equals 0. Okay, so now I've got to figure out factors of this, what is it, a 360,000, that's what it is, 360,000 number. Factors of that have a sum of 169. I could play around for a little bit, but I don't know, has to add up to 169. What if I had maybe like a 144 times 25? Nowhere close. So maybe what I want to do then, I mean, I could guess and check, but that's a big number right there. I might just go ahead and go quadratic formula on it. So I've got a little bit of space over here. Let's come do quadratic formula. So x equals negative b, so 169, plus or minus the square root of b squared which is going to be, I don't know that I have enough room here, 28561 minus 4 times a times c, 36123 4. Ooh, messy. All right, so then in my calculator, I'm going to subtract those. Do you know what's going to happen here? I got a negative number under there. I hadn't even finished and be all over 2a, which would ultimately just be a 2, but none of that really matters because I ended up with an imaginary solution here. Now, at this point, I'm going to bail because I didn't want to dig too deep into this, but I did want to show you how that can play out, that maybe you might get imaginary answers. Now, what does that mean in this problem? Well, it means that I can't have a triangle that would work out, that it'd have a hypotenuse of 13 and still have this area of 300. So in this situation, I'd have to say it's a no solution, but it could have just easily have worked. And I just kind of wanted to show you how to work through one of these where you're having to come up with those equations on your own. So kind of multi-purpose problem here that I gave you. Okay, so now I have one for you to try. This one is going to work out. Let's see if you could come up with your two equations on this. So let's start with that. Just get the two equations and let's see, we're talking about a rectangle. So let's use an L and a W for length and width, just for some consistency between our equations. All right, go write your two equations. Pause the video. All right, so these should have been the two equations, one for perimeter, one for area. And now we have to decide kind of what we want to do as far as isolating a variable. So I have options here. I could divide on this second equation. I could just divide by L or divide by W on both sides. It does sort of create a fraction. So if you don't like that, another option, you could isolate one of these variables. That wouldn't play out too bad. And then you could plug it in over here. Last time we did the division, so I'm going to show you how to do it if you do the other direction. So I don't know, for no particular reason, I'm going to isolate the L in that top equation. So that means subtracting the 2W and dividing by 2. Now, one of the reasons I chose to do this is because I could see that it was going to divide by that 2 nicely. So 40 divided by 2, and then 2W divided by 2. So now this is what I'm going to take to go plug in right there. So I'm going to have a 20 minus W times the W. So then distribute. So I am going to still end up with that W squared going on. I brought my 96 over. I can see that I have a W squared, I have a W, I have a constant. This is going to be a factoring problem. Now, one of the things I don't love, though, is that this W squared is negative. So I would move everything to the other side to get this to be positive. And then I'm going to let you take a minute and go figure out the factors or the solutions for this. So move everything to the other side and then try to factor. Pause the video. All right, I got the width to either be 12 or 8. And really what that is really it's you don't really distinguish which one's the width, which one's the length when you're looking at the picture so much. So you could see that if I plugged 12 into the equation right here, plug that in for this W and solve, well, 96 divided by 12 is 8. So ultimately your length and width are 8. I'm sorry, your length and width are a 12 and an 8. If we wanted to assume the length is the longer one, then I'd say that the length is equal to the 12 feet and the width would be equal to the 8 feet. Ultimately, it's an 8 by 12 rectangle. All right, that's all I've got for you. Go give your homework a shot. Good luck.